Hello, students. This is Mr. Nguyen here. Today we're going to be talking about theorems of central angles and inscribed angles. So we're going to be applying these theorems to solve problems. But first, we need to talk about some definitions so that you know what they are. So first off, a central angle is the angle that is formed when you have two radii um, intersect in the center. So pretty much the central angle is the angle in the center of a circle. Okay. Um, Next is the inscribed angle. The inscribed angle is the angle that is created by either two secants or two chords or a secant and a tangent or a chord and a tangent. Um, anyway, this angle is actually on the circle on the inside, but it's on the circle, right? The vertex is on the circle. So two segments that created this inscribed angle. Okay, inscribed means that the shape is inside the circle. Okay. And then we have what we call the intercepted arc. We need to know this arc because this arc is intercepted by either the central angle or the inscribed angle, right? Each any of these angle have an intercepted arc. Okay, is the arc that sort of I guess you can say that is right directly opposite of the angle, right, on the opposite side of the angle. So it's included in within that angle, right? So that's the it's called the intercepted arc here. Okay. So let's talk about the first one. The first one is fairly easy. It's called the central angle theorem. It says the measure of the central angle is equal to the measure of the intercepted arc. So, for example, here we have the intercepted arc YZ, okay, and the central angle YOZ, okay. As you can see, these two measurements are the same, okay. So the arc and the central angle is has the same measure. So let's look at this example real quick. So here we have a circle. AD is the diameter, okay, and we need to figure out what these x, y, z, what the values are. So x is the central angle for AOB, and the arc for this central angle is 25. Therefore, the central angle is also 25, right? So the arc AB, the little arc here, AB, is 25 degrees. So the central angle for that arc, that intercepted arc, is also 25. And we can use the same reasoning for arc CD and central angle COD, right? So COD is the central angle, and its measures is 55 degrees. So right opposite of that is arc CD, which is the value for Z. So that should also be 55 degrees. Now let's talk about Y. Y doesn't have an arc, right? Doesn't have the measure for the arc. But as you know, half of a circle is 180 degrees. So if you take 55 and you add to 25 and you subtract that from 180, you'll end up with the arc for BC, which is also the central angle Y. So Y end up being 180 minus 80, and that's 100 degrees. Okay. Here's another example. We have a circle here, circle O, with given different measures for the arcs. However, each of them have an x in it. So where do we start? Well, we start with what we know about the circle. We need an equation, right? And before we can set up the equation, we need some kind of relationship. Well, the relationship among all of these arcs that make up the entire circle is 360 degrees, right? So you could say that arc 1 plus arc 2 plus arc 3 plus arc 4 going in that direction is 360. So which means we are going to virtually add all of these arcs together and set that equal to 360, like that. Okay. So we have 3x plus 15 right here, which is arc DA, okay, going that direction. And then we have x here, which is arc AB, okay. And we have 4x here, which is arc BC. And then we have 2x plus 15, which is arc CD. So I'm adding them all together and set it equal to 360 because the sum of all of these arcs would be 360. And then I'm going to solve this equation. I'm going to combine like terms. So 3x plus 4x plus 2x is 10x. And then 15 plus 15 is 30. And this becomes two-step equation. I'm going to subtract 30, get 330. And then I'm going to divide by 10 to get x by itself. So I get x to equal to 33. Now, x is arc AB, which is also going to be the measure for the central angle AOB, 33. Okay, so the central angle is equal to the arc, right? So the central angle 33 is equal to the arc. Next, we're going to do arc BC. Well, arc BC is 4x. So we're going to substitute the 33 in there and multiply by 4 to get us 132 for the central angle BOC. Okay? And then we use the same thing for arc CD. Arc CD, we're going to substitute 33 in there. So 2 times 33 plus 15 will give us 81, which is the central angle for COD. And then lastly, we do 3 times 33 plus 15 to give us 114, which is central angle DOA or AOD. Either way you say it, but the O needs to be in the middle, right? So here are our answers. So pretty much you can see the recurring theme for geometry. You set up the relationship, add them all together equal to 360, solve your equation, get an answer, get a solution for your variable, and then substitute the variables in to answer the actual questions of the problem, okay? Next, there are 3 inscribed angle theorems. We're going to talk about the first one, okay? The first one says, the measure of an inscribed angle, it's half of the intercepted arc. Now, it's different than the central angle. The central angle, it's equal to the intercepted arc. But the inscribed angle, it's only half of it, right? So the inscribed angle is right here, the one that is over here, that's on the circle right here, right? And then the intercepted arc over here. So if this arc is like 100, the angle will be half of that, which is 50, right? So how do we say that? If the arc is x degree, then you take x and you divide it by 2 to get the inscribed angle. Okay, so pretty straightforward, no tricks here. Okay, let's look at an example. So you could have an inscribed angle made by 2 chords, right? And let's say the relationship is 1/2, right? So the angle is 1/2 of the arc. So if they give you the arc of 75 degrees, you divide that 75 by 2 and you get 37.5, which is angle B or angle ABC. Okay, that's the inscribed angle. Or you can have an inscribed angle made by a chord and a tangent. You can see here, this angle right here is also an inscribed angle, right? And the arc that is opposite of that angle, it's right here. This is the intercepted arc right here, arc AB, okay? This minor arc right here. So the angle is half of that. So if I give you that arc, 112, and you divide it by 2, to get 56, that would be your inscribed angle. It's half of that, okay? So the inscribed angle is half of the intercepted arc. Here's another example. Okay, in this example, we got to solve the equation to find the value of x. So they give you the intercepted arc right here for this inscribed angle. The arc is 120, and the angle, and now if the arc is 120, we know the arc is half of that, the angle is half of that, so the angle should be 60 degrees. Well, to solve for x, you just let 60 equal to 3x minus 3, right? Because that is the angle, okay? And then you solve the equation. So add 3 and divide it by 3. You get x equals to 21. Talk about the second theorem of the inscribed angle theorems. It says if 2 inscribed angles intercept the same arc, then they are congruent. Well, it makes sense if angle 1, if this inscribed angle has this intercepted arc over here, and then angle 2 also have this intercepted arc over here, that means the two angles must be equal to each other. That's why they intercepted the same arc. Okay, so this is more like, it's almost common sense. Okay, but it is a theorem. So if you have two inscribed angles that intercept the same arc, then those two angles are the same. That's what the theorem says. Okay, so let's look at this example. And let's see if you can see the intercepted arc. Here's angle 1. Angle 1 is R. If you look directly from opposite of angle 1, this is the arc that it intercepts, right? So ST. And then if you look at angle 2 right here, and you look directly opposite of that, it is also intercepting ST. So ST is the common intercepted arc for angle 1 and angle 2. So if you find one angle, you'll find the other one. Okay, so what did they give us? Well, they give us ST. ST is 68, which means angle 1 would be half of that. It's 34. And because angle 1 and angle 2 are the same, angle 2 would also be 34 degrees because they share the same intercepted arc. Okay, therefore the angles are the same. Let's talk about the third theorem and the final theorem for inscribed angle. It says if the inscribed angle of a polygon, the opposite angles are the same. Okay, so if you have a polygon inscribed inside a circle, the opposite of this quadrilateral, the opposite angles are always supplementary. Okay, so angle A and angle C make up 180 degrees. Angle B and angle D make up 180 degrees. So this is the relationship right here. Every single time, it doesn't matter what your quadrilateral looks like, the opposite angles will always add to 180, right? Always. So let's use that relationship really quick here. We have a polygon, a four-sided polygon quadrilateral inscribed inside a circle. And we know we're supposed to find the value of x and y. Well, we just learned from that theorem that angle B and angle D would make up 180 degrees. So if we know angle D, we could subtract angle D from 180 degrees to give us angle B, which is the value for x, right? So we know angle B and D add up to 180. And so we substitute the values in, right? Angle B is x, angle D is 112. So we subtract 112, we get x equals to 68 degrees, okay? Now we can use the same thing, same theorem for C and A, or A and C. Angle A plus angle C equals 180. And angle A is y, and angle C is x plus 10. Now, we have two variables in one equation. But lucky for us, we already know one of the variable. We already know what x is. So we substitute 68 in for x. Okay, so that will become 78 because it's adding 10 to it, right? So y plus 78 equals to 180. And then you subtract 78 to get y equals 102. And that wraps up our theorems for central angle and inscribed angles. I hope to this has been helpful lesson, and I will see you guys next time. Thank you for watching. Bye bye.